let's keep going. Let's see what else we got. Okay. So we have this, and let's first ask ourselves, okay, wait, we're not doing this in sort of like, how are we storing all of this? Because I think that that's important. Well, the way that we store it is that we take the points of every single living organism on the map. So here, 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 and here. And let's put a couple more of these in here. Okay, so this is such and such point, this is such and such point. It keeps going through these and it creates these points. So the actual, it's not stored in a specific storage system. It's stored in a system that has these as values. So instead of making it so that we have a bunch of arrays and then an array that goes through those arrays, we have a system where every object has an x and y coordinate, and those values are used as the way to be able to figure out how to be able to work with things. Now, how do we judge the difference between the two? We use the isInstanceOf operator as sort of our working way of being able to figure out this stuff. So we go, well, is this an instance of a mite? And it's like, yeah, it is. So we're like, okay, cool. Then we do this. And then if it goes, oh, is this an instance of a mite? No, no, it's not. Okay, well, is it an instance of a berry? And it's like, yes, yes, it is. That way, you can be able to use different ways to be able to distinguish between different things without requiring the the parent class to have all of these extra things added to it. Now I could show this here for the people who may not understand code that much, where essentially you need to have something that says, okay, all of these other objects that we have these base things, so that we can basically work with them a bit better. It's kind of like how a car and a truck. A car and a truck are very similar. They both have four wheels. They both have a dashboard and a steering wheel and everything. But a truck has a bed and a car doesn't. Which means that you could say that you have, say, motorized vehicles as your class, as your base class. And then you have cars and trucks as your sort of child classes. So if you wanted to see the number of wheels, those would both be things of cars and of trucks, and that would be something that would be in the base class. But motorcycles have two wheels, and that way you can be able to sort of distinguish between them. So, but they both all have wheels. So we use the base system in order to be able to figure this stuff out. So we have just the base stuff that we need, like names, x and y coordinates, and this boolean called isDead. So isDead is basically used as a way to be able to remove things from what we call the existence plane. Okay? And if something gets removed from the existence plane, it doesn't exist anymore and it won't be rendered. Okay? Now, I will admit that this causes memory issues, because essentially you're still storing these objects without deleting them. But to be honest, I was trying to get this done, and there's a whole bunch of other bad stuff that I did also. So we'll cover that later. We'll cover that in a bit. Okay. So this has all of these methods in order to be able to deal with this, and then mite has all of these methods too. But for all the coders out there, I definitely think that for commenting, that this is something that we should get in the practice of doing more, which is that if you have a variable in the commenting section, you should tell where that variable is being used. Because if you tell where that variable is being used, then it's a lot easier to track down what the problem is with that variable when you have an error. And it makes things just a whole bunch easier. So let's go, if we go over here, back to our example, let's say that we want the mites to be able to survive for quite a bit longer. Well, how do we do that? Well, the way that we do it is to make it so that we add, first of all, our first formal mutation, not one that's accidental. So the way that we do that is that essentially we say, okay, let's give them biases. When they move in a random direction. They're like, okay, I could move here, I could move here, I could move here, I could move here. But that's very random. Okay, that's essentially if you were to plop someone in the middle of field, they were to pick one random direction and then eventually they get lost and they just kind of start going in circles. What we're basically doing is we're going, okay, you have this need to go in this direction, kind of like a homing pigeon. Okay, so say their need is in this direction, okay, which means that with their vectors, they're always going to want to move in that direction. And I'll show you what I mean. In our movement class, okay, the original of what it was that we had the x value plus this sort of random value of moving in any direction of any choosing, okay, which is a vector between -1 and 1, which means that since it's an integer, it can only be -1, 0, and 1. 0 means that it doesn't move, -1 means that it moves to the left, and 1 means that it moves to the right. So if you have down here, if you have the random bias of +1, okay, the random movement of +1, and you have the bias movement of -1, these cancel out, which means that it just doesn't move in that direction. But if your bias is in this direction, that's great, because they add together, because 1 + 1 is obviously going to be more than 1, and it's not going to be negative, and it's not going to be 0. So what you can do is you can do some special code to make it so that instead of it jumping forward to space 2, because it's not supposed to do that yet, it stays at 1, okay? Now, let's say that it's 0, though. Well, that means that it still moves in the same direction because of the fact that it just doesn't help, but it also doesn't hinder. But it also means that in the other case of that the bias is 1 and the randomness is 0, it still works. Now this also works on the y-axis, but I wanted to explain it on the x because it kind of just makes a bit more sense. So, essentially to sum this up, we are making it so that the mites want to move in a direction, essentially sort of giving them this spidey sense of a pull towards a direction that they should go. Now, it doesn't mean that they're always going to go in that direction because of this randomness, okay? But it does mean that they will want to go in this direction. So, say that you have a wanting to go in this direction because the berries are all down here. Now, you see, the mite doesn't know that the berries are down there. The mite doesn't know anything, okay? It is completely oblivious. All it wants to do is to eat berries, okay? But when it does eat 2 berries, say that there's 2 berries down here, okay? But when it does eat 2 berries, it eats them and then it reproduces. Now, that style was successful. It moved down here, it was able to reproduce, so therefore there should be, most likely, more berries in the same direction. So it reproduces. This new mite should have the same bias as the old mite, because if it does, then that means that both of these will reproduce in the same in the same way, and it will grow that part of the gene pool, or it will grow that sort of mutation. Okay, so say that this one starts to move, and it moves in the same direction. Okay, clones the direction that its dad was moving in, and it moves past this. Okay, and so it reproduces when it hits it, and it is able to keep the system going. It's able to make it so that that they're able to reproduce. And if you were to have an abundance of berries in the bottom right hand corner, this would work, and essentially all of your mites would be able to do this. Now, let's say that you were to sort of get to a point where, say, this clump is everything. Going past this point, there's not many berries. Well, if the mites were to be able to reproduce, and the next mite were to reproduce, and its vector were to be mutated and were to be less, say, maybe just nullified, so that it doesn't really move in a direction so far, that any direction that isn't, so it doesn't have any bias, so it's just going to move in a random direction. It will stay within this area, which means that it kind of just moves in this cloud instead of in a direction, but it will stay within the berries, and it will be able to eat them.